Hey folks, welcome to episode 7. It's been a while, but I want to finally give you an update on where we are with our Philco 41-245. It's been a while because I've been having some trouble with this thing, which is very customary for a radio I work on. So what we're going to do is we're going to reverse engineer a little bit here, and I'm going to start the video off with the radio playing, and then we're going to explain all the things that we learned in case any of you can benefit from it. So let's do that first. Let's put the power up. And you will hear we have really good audio coming out of this thing. Let's just give it a moment to warm up. And then I'll explain all the problems we had. Okay, so there she is. Let's cut the power. Alright, so where do we start? Well, let me reposition the camera and then we'll get into our story. Be right back. Okay, those of you that follow my videos know that I'm never ashamed to talk about the mistakes, and that's going to be the same thing here. So let's talk about what happened when we first tried our radio. So we put in that Philco transformer. You'll notice this is not the Philco transformer, and I'll explain that in a moment. The Philco transformer that we had in there had a short inside of it, and what was happening was that I was basically having unstable voltage underneath. So it wasn't a dead short, but it was causing problems on the radio. So I ended up having to get that transformer out of there. As you remember, it was a Philco transformer for a Philco 84 Cathedral. So I had to go and find a suitable transformer to use in the radio. And I will explain to you how I found this transformer, the right one, and how I chose that and used logic to figure that out. So essentially, what I ended up doing is putting in this transformer, which is a Hammond 270 DAX, and that's the transformer that will work just fine in this radio. So we put this transformer in, and let's take a look on the bottom side, right here. And we put the transformer in, and radio still did not work. Really, really strange. And what was happening is this filter cap here, which is originally a 12 microfarad cap, which basically goes right across the field coil. If I had it connected to where it was supposed to be connected, I had audio, but I had a 60 cycle hum. Real strange. If I took this cap here and removed it, no hum. So I said to myself, what the hell's that? And just to show you as a point of reference on the schematic, let's get into that here. This is the capacitor we're talking about right here. So essentially, if I removed this end of the cap, field coil worked. I had a hum, but the radio was dead. If I connected it, I had zilcho, right? And I'm going like, what is that all about? So one thing led to another, and I determined that, but this is with the new transformer now. I determined that basically, with the help of Brendan, obviously, that I needed to add some additional resistance, because right here on this schematic, you'll see right here that coming right out of the power supply, the high voltage side, there's a 220 ohm and a 68 ohm. And because of the difference in the transformer, I had to increase that, and I increased this 68 ohm resistor to a 470 ohm resistor, and I used the decade box to figure that out. And the way I figured that out is by trying to get a negative 15 volts or greater on pin 3 of the output tube right here, right? This is the area here where I needed to have minus 15 or more. And you look at the tube data to understand what that means. So, so essentially, I replaced that resistor right here. And by doing that, I was getting minus 15 volts, which is great. So good. But with this cap connected right here, still no audio. So now we get into a philosophical discussion about how you troubleshoot. So, so what I was doing was what is affectionately now known as shotgunning, which is, not following a process, running all over the place, trying to figure out what the issue was, replacing components that didn't need to be replaced, doing all kinds of things. When in theory, I could have used a very logical set of steps to figure out what was wrong. We know that this capacitor right here was part of the problem. We know that the field coil was part of the problem. And if we look where this connection goes, it comes right up here. It comes across here, but it also comes up here. And part of it branches off to the speaker, to the output transformer. And part of it comes up here to this connection that goes back to the output tube. So what would stop this from working? Well, what I started to do is poke around the bottom of the radio and the output tube connections, and I found that the wire, a red wire that in there that was old wire with the old insulation, was shorted, broken, open. Didn't know that. It wasn't broken on the underneath the chassis. You couldn't see it visually, but it was broken. So it's basically this red wire here. Right here it says red, and this red wire, which comes up here and then comes down here and goes to the tube, was broken. So I put a jumper on it, a pair of, a gator wire on it. Radio's working. But what I want to talk about today is the process, first of all, for replacing the transformer. That's important. And I think it's important that you understand how you find out what kind of transformer you could use, right? I purposely did not ask for help on that. Normally I would have asked for help. I would have probably written an email to Brendan and say, hey Brendan, I need some help with the transformer. I didn't want to do that. I wanted to do it by myself. I wanted to pick the right one, make sure that it's the right one, and it was going to work in this radio. So let me stop this for a moment. I will show you the process that I used to find the right transformer for this thing. It was very inexpensive. I think it was $40 or something, and it's now working. And remember, this radio is 1941. It's my mother, right? It's being restored in memory of my mom. I told you that in the last video. So let's go through the process that I followed to get the transformer, and then we'll go from there. Okay, on the internet I found something called the Philco Parts Catalog, 1942. This is a 1941 radio, so that would make sense. Let's open that up. We'll pull the shot back, and you'll see that we get a nice reference of all the parts. So let's take a look at the index and take a look at transformers. That's what we're looking for here, transformers. And we see that power transformers right here are on page 30, 31, and 32. Now what we're doing here is looking for the original specs of what the transformer needs to be, right? Can't tell that from underneath the radio, right? So we're fortunate that we have this, this reference guide. There is a way to test it, obviously. I shouldn't say there's no way to do it, but this way is certainly easier. So what I know by looking at the parts list of my radio is that the transformer that was in there was a part number 328064, right there, okay? And you'll see it's a 7-volt filament, 6.3 volts obviously, and we know that the high voltage side is 512, and we know that it's 54 milliamps, and we know that it's 3 amps here. So let me just go through this again because I just confused you. So basically what we have here, let's go through it. We have a 6.4 volt filament at 3 amps. We have a 512 center tap connection at 54 milliamps. And here's the dimensions, okay? It's 50 to 60 cycle, 115 to 120 volt. So what we're going to do on a piece of paper is we're going to jot those numbers down. So let's get this situated here. There you go. So we need, and it's not focusing. There we go. We need 6.3 at 3 amps, and we need 512 center tap, and we need that to be 54 DC milliamps. DC milliamps. Okay, there we go. That's what we need to replace it. So then what I did is I went to Hammond's website. Let's open that up. Okay, so here's our power transformers. Now, what are we looking for? We're looking for a, I would say we're looking for a high voltage plate and filament right here. Classic high voltage tube and plate. So we're going to click here. And they give you a list of all these transformers you've got here. So obviously we're looking for 115 volts, 60 hertz. Remember, we're looking for 512 volts center tap at 54 DC milliamps. So I came down this chart and found this 117 volt, 50-60 hertz, 520 volt center tap at 104 milliamps. So the milliamps are a little bit higher. That's okay. Also, our filament is at 6.3 volts at 3.5 amps. So that's good. And the dimensions are actually almost perfect. So we chose the 270 DAX. That's the transformer that we put in the radio. And you'll see here that the options are, it has 117 and 125 volts. Here's the center tap. Here's the filaments. This is perfect. All right, so the transformer that we have in the radio actually fits in the same footprint. I didn't really have to drill any holes, just one. And it's electrically almost the same transformer. So that's what I did, right? I was fortunate enough to get the stats on the old one, and I matched it up as close as I could to the new one. So in case you ever want to do that, get the part number, get the specs, and then check out Hammond, okay? Let's go back to the radio. All right, next I want to talk about this output tube. If you heard me mention earlier, when I put the transformer in, I was supposed to be getting a negative 15 volts or higher on that grid, and that just wasn't the case, right? And this was a short sighting on my part because I didn't follow a standard set of rules. I didn't go around, check all the voltages and make sure that they were in the right place. I just, nilly-willy went around on the plates and said, okay, this looks good, that looks good. And this I had the help of Brendan on, and he educated me a little bit on Philcos. That when Philco made radios back then, they were trying to use, they actually designed them as if they were Class A amplifiers. I don't know if you know that or not. And by doing that, their output tube scheme is different than other radios. So if you look at the tube data, you'll see that there is a section here for typical operation for a single Class A. And if you look at the grid voltage, I'm going to zoom in so you can see it. If you look at the grid voltage right here, it's minus 7 or minus 18. Okay? So that's what I should be getting. I was not getting that. I was getting like minus 10. So that's why I needed to put the decade box in and change that resistor from 68 ohms to 470 ohms, because I wasn't meeting up the specs of this tube, which is needed for the radio. And you'll see here there's a difference between the two columns, the plate voltage. So the plate voltage here for 100, you would get minus 7. Plate voltage here is 250, and on this radio the plate voltage is around 220, I think. And that's why you're looking for minus 18 volts. So again, there's a clue that I didn't know about or didn't think about when I was troubleshooting the radio. So you got to remember, when you're troubleshooting a problem like this, you have to know what voltages you're going to expect to see. And the tube data tells you that. It just doesn't get any easier than that. And again, if you keep shotgunning things like I was, you'll be here for weeks like I was, right? I wasn't organized. I wasn't really doing a good job of understanding what happened here. So that's why I ended up having to replace that resistor. So with that said, the wire that was open is this wire right here. Here's the piece of wire that I found that was open. I did a continuity test from right here, which is pin 3 of my output tube. Let's move this so you can see it. Pin 3 of my output tube over to this connection right here, which is basically part of my filter cap. This piece of wire is open, or at least it was when I ran the continuity test. So what I did is put a gator wire in, and I've since replaced it with this red wire right here. And the radio now works. And I've got the cap connected where it should be, and everything is working as it should have been. So this radio is essentially good to go. There's a few things I still need to do on it, obviously. So now that we have a working radio, next thing we need to do is we need to reinstall the push buttons, right? So this is the push button assembly right here, and the push button assembly attaches right here. There's 3 wires coming to the top, one here, one here, and one here. We're going to run new wire down underneath the chassis, and we're going to connect it to these 3 spots. 1, 2, 3. These 2 here are the power switch. These go right here to the power switch. So we're going to remount these, and then obviously we'll be able to test the other bands. I don't think we'll find anything on there, but you never know. And then we're going to do a full alignment. So number 41 is almost ready to go, and then then we'll be able to start working on the case and get the case where it needs to be. But the point I wanted to make with you with this video is, if you're troubleshooting a problem, you got to get organized. You have to know your signal flow. There's lots of great videos on the internet for signal flow. All American 5, I think, is one of our YouTube friends that does that. He has a great video on signal flow. Talks about how signal goes from the RF all the way through to the output. Also talks about putting signal tracers and audio signals and RF signals into a radio and understanding how things work. What I did on this radio before I found that broken wire is I put a 9-volt battery across the various output points to see if the coils were open. I thought maybe I had an open field coil or a speaker coil or an output transformer. And when I put the 9-volt battery across there, I was getting clicks, which tell me everything is working. So you have to follow the signals flow. And like I told you, in an upcoming video, it's going to be a multi-part video. I'm going to talk about what you do when you get a radio first out of the box, what you don't do, and then the logical steps that you take to ensure that you can restore the radio, and then what you do to troubleshoot. Now, I'm going to do this more for me probably than for you, but when I do it, it'll hopefully be like a 101 primer for anyone that's new trying to work on radios, and I will apply the knowledge that I'm getting from our friend Brendan, who is really patient guy, and really, really helpful. But no offense, Brendan, I really did try to resolve this one on my own. It was close. I almost did. You gave me a little bit of help. So we are in great shape with this radio. Here's our Hammond 270 DAX. Works perfectly. If you need a transformer, remember what I told you. Know what your baseline is, and then go look for the right transformer, and hopefully you find one that's at a reasonable price like I did. And here she is. So I apologize for being gone so long. It's been a few weeks again, and not all because I'm troubleshooting this thing. It's busy with work and bands and stuff. But we're back on the saddle again. So next step on this, we'll come back in the next episode with the push buttons connected, and we'll do an alignment. I'll show you how we do that. And I think we will be in great shape on this thing, and then we'll look at the cabinet and see what we need to do there. All right, so that's it for now, folks. Good to be back. I hope everybody's doing well, and I hope everybody has a great day. Thanks.